Okay, so now we're going to move on to the second topic for section 10.3, which is graph isomorphism. We'll begin with this question. Are these graphs the same? If you'd like, you can pause the video and take a minute to ponder that question and see what you think the answer is. All right, so are they the same? Well, what does it mean for graphs to be the same? They've got to have the same number of vertices, and those vertices have to be connected in the same ways with the same edges. I mean, you could say, well, they have to look the same, except they don't necessarily. Like, remember that the way you arrange the vertices and like how exactly you draw the edges doesn't really matter. So, for example, take this in the second graph, G2, take this vertex Z over here. Let's actually move that and put it up here. So I'm going to remove Z and put it up there. So it was adjacent to Y and X. So those, I'm basically going to imagine dragging the vertex up here, and those edges are going to come with it. And it's now going to look something like like that. Okay, so that's a new graph. And now if I compare these look very similar to each other, right? They both are basically two triangles, right? Two triangles, or you can think of it as a square with a diagonal slash through it. They do look like they're maybe a bit mirror image of one another because this diagonal slash is going sort of up and to the right, whereas this is up and to the left. But that means they're pretty much the same, right? If I mirror image them, I can just drag the Z and Y vertices over to the other side. But they're not exactly the same. And the reason they're not exactly the same is because the vertex sets V1 and V2 are not actually the same set. In graph 1, the vertex set is ABCD, whereas in graph 2, it's XYZW. So technically, they're not the same, but they're pretty much the same. I mean, we could say, but they're basically the same thing, right? So we want to formalize this idea of these graphs are basically the same. All you got to do is rearrange where the vertices are and maybe rename those vertices, and then it would be the same thing, right? The way to formalize that idea is as something called a graph isomorphism. So isomorphism, that word is, I think, Greek. Iso means same and morph means shape. So a graph isomorphism is actually a function that establishes that two graphs are the same shape. They're basically the same graph. So I'm going to pause the video and write down a definition. All right, so there is our definition for graph isomorphism. Let's look at it. Two simple graphs, and this can be extended to non-simple graphs, but we'll begin with the simple graph version. Two simple graphs, G1 and G2, with vertex sets V1 and V2 and edge sets E1 and E2, are called isomorphic if there exists a function f from the first vertex set to the second vertex set, or vice versa, it doesn't really matter, which is a bijection, such that given any two vertices in V1, given any AB in V1, there's an edge from A to B in the first graph in E1 if and only if there's an edge between their images, f of A and f of B, in the second graph. So what this basically means that f is a bijection between the vertices. And remember that a bijection means that the sets have to be exactly the same cardinality. So that establishes that the number of vertices in the two graphs has to be the same. And then also, not only is it a bijection, also f is a function which preserves adjacency. That means that if two vertices are adjacent in the original graph, if you apply the function f to those vertices, then the resulting images will also be adjacent in the second graph. And vice versa as well. The inverse of f inverse, which will exist since it's a bijection, must also preserve adjacency going back. So whatever adjacency relationships, whatever edges we have in the first graph, we still have those exact same edges between the images of the vertices under that map. So that's what a graph isomorphism is. It is this bijection. There's some notation we use here. When such a bijection exists, when that isomorphism exists, we say G1 is isomorphic to, using this squiggle on top, straight line on bottom. It's kind of like an equal sign, but with a top squiggle. So that means G1 is isomorphic to G2.